Welcome to ToolTech. I've been prototyping a system to make DIY multi-tools. Previously, I've been experimenting with putting a spring in the tool itself and a complicated shaped pivot. Right now, I figure out if you need to machine a pivot, that will be very expensive and slow and whatnot. So the question was, can we use one of these spacers, these hexagonal little pivots that are used for electronics? They have an hexagonal shape. So if we build a spring into the tool and have an hexagonal attachment there, when we have a tool built, a real tool with a metal, so then it will have this kind of ratcheting action almost, and then this will be the deployed position. Now this tool has a stopper here, so we can resist forces in this direction, and then the spacer, which acts as a pivot, can resist force in this direction. And then if we have forces in this direction, the spring will resist it to some extent until we overcome the spring. And then we can fold it back into a folded position. So here's one that's completely assembled. So to deploy the tool, we ratchet it out. By the way, this makes this ratcheting sound kind of like the Smith blade, which was unintended. So here we have a somewhat robust deployment. If it was like a saw, it can resist forces because of that little bridge there. If it's a screwdriver or some sort of awl or something, the pivot resists that force, and then the spring prevents it from moving this way with small forces. But if we overcome the spring, then we can fold it. So this will be a very easy way to build a tool, because you need an off-the-shelf part for the pivot. Then the spring is built into the tool, so you don't need to put a lot of springs. There are some tools where they have springs that are very heavy, and that's bad for portability. So I have not seen tools this way, where the tool is a spring. One question would be, will the heat treatment for spring be adequate for the heat treatment that you need for tools? That's kind of a bit of an open question. Can this be made with enough tolerance to make something pretty solid working? So it seems to be the case here. This has a bit of wobble, but not too much. Something I learned in this process is that depending on how you build the spring, it can have a bit of a ratcheting motion. So in this direction, it requires very little force to move, but in the opposite, it requires more. So that's why we kind of have to mount it certain way, such that we have a big resistance, so the tool doesn't accidentally get moved too easily. If it was this way, it doesn't really work. I guess the other question will be, could you use this as a ratchet to make a very small tool for like a bit driver? There's already some that had a similar principle, and they were able to ratchet, so that could be also something else to explore. But at the moment, this proof of concept seems to show that yes, you can build a spring into the tool and use an hexagonal spacer to provide a shaped pivot, so you don't need to machine anything. And then the scales will have to accommodate the pivot. So either if you want to make this of 2D parts, maybe you can have 2 layers, one with the hexagon hole and one with the circular hole for the screw. So it's different kind of details, but overall this kind of proves that you could build this simplified system using just off-the-shelf parts and 2D cut pieces, which are easier to design and make than more complex things or things with lots of large part count. Basically, if you have so many springs and locks, you start to increase the cost and the work needed to build the tool. So I think this simplification looks somewhat promising. So I might try to test it later on with metal parts. I think this is easy enough to try maybe next time. Not sure if I'll do it, but maybe yes. Thank you for watching. If you like this type of stuff, please subscribe or like. See you next time.